Cool for the people who are just getting into electronics and whose introduction to it was likely through an Arduino. You probably use the Arduino to create things like blink and fade, like here, and programming an LED to fade in, fade out using PWM. Well, you really don't need a microcontroller to do things like that, and something I recommend that people do after they've created something using a microcontroller, if it's simple enough where it doesn't need things like LCDs, or it's not driving something like that, something fancy that's using some kind of protocol, you can try and create it on a breadboard using just basic components, because it's kind of its own challenge, and also if it's something you're going to produce later, again, and mass produce, it's cheaper. And there's a description for this circuit in the description of this video. But essentially what you have here are two trim pots which control the fade in and fade out of this LED, with a signal being generated by the 555 right there. And with the capacitor there, the square wave becomes a sawtooth wave, which to the human eye looks fairly linear and is similar to the fade. This one here, this trim pot, controls the frequency of the fade in and fade out. So as we increase the resistance, which in this case is equivalent to increasing the delay time between each incremental fade up and fade down. Creates a nice, kind of cool, very rich breathing, very similar to the Arduino, but in this case, instead of using PWM like is on the microcontroller, we're using a true analog signal here by taking the square wave from the 555 and converting it into a sawtooth, where you have a voltage range, which this LED is actually reflecting the voltage. It's not being turned on quickly and then shut down. And in fact, we can even use this signal to drive a higher current device, like a 12-volt lamp. And again, just use the trim pots to control it. But in this case, use a higher current transistor. In this case, the TIP120 instead of the 2N2222, which was driving the little 5mm LED. And another note is that you really can't use a MOSFET in this situation. You really need to use a non-latching BJT, something current driven, not voltage driven, because that way it will act like a variable resistor, where a small current, when it's trickling discharge, it will result in just a dim current flowing through the light, or a rapid charge, rapid current rise, rapid fade in, rapid discharge, rapid fade out. Small transistor, you could even use this to drive something like this buzzer here, and with the three trim pots used in combination with each other, this almost is like a neat little tone generator which you can use to create your own custom alarm sounds. Like if you were creating a circuit and you needed an alarm, you could use a 555 and this buzzer and these little combinations of components to create your own custom alarm noise, which would be kind of cool, especially if it's in an area where you need to distinguish your signal from something else's. You can use this to kind of create something unique that you would be able to recognize. But I'm not going to be doing that today because my girlfriend is asleep in the other room and I really don't want to wake her up, because at 18 volts right now, that thing is loud. But that wraps it up for this video. If you like what you saw, consider giving it a thumbs up and subscribing to my channel. And I'm going to have some cool videos coming up in the future, in which we're going to be doing things with classic circuits, as well as microcontrollers, and even rockets, again. In next videos coming up, we're going to include things like some stuff with the AT1085, and my favorite new project, going to be converting a Power Wheels into a large 2.4 gigahertz driven RC car. That one's going to be a lot of fun, and I know a lot of you would enjoy it, so if you like what you saw, come around again. See ya!